Hi there and welcome. I am Marty Yan, CEO of Mercury. Today, I want to talk to you about a challenge that engineers in medical electronics know all too well: electromagnetic interference, or EMI. We all know EMI can cause serious issues in sensitive medical equipment. Just think about how you are asked to turn off your mobile phone to airplane mode during a flight, because the EMI from mobile phones could interfere with cockpit instruments. That's EMI in real life. Now imagine that same kind of interference happening in medical devices like ECG or MRI, where precision matters. In this video, I will show you how our low EMI spectrum oscillator can help you solve that problem and ensure your system passes strict EMC standards with ease. Before we get into technical details, let me give you a quick intro about Mercury. We were based in Taipei, Taiwan, and we have been around since 1970. That is over 55 years of experience in making crystal components. We were the first crystal manufacturer in Taiwan. We produce crystal units, crystal oscillators, and crystal filters. We were certified with ISO 14000 and the IFTF 16949 for automotive applications. But what makes us apart is our focus on oscillator innovating, including first one, oscillators with differential output for networking applications. The second, programmable oscillators for fast delivery. Third, and of course, low EMI oscillators, which we will dive into today. Let us talk about EMI in context of medical devices. Devices like ECG and MRI are incredibly sensitive. Even minor interference from nearby electronics can distort the signals or make the equipment malfunction. That is why medical systems have to meet the strict EMC standard like IEC 60601-1-2 and CISPR 11. If your design does not pass, you cannot ship it. Now, EMI usually comes from two sources: the power supply and clock oscillators. And while power supply are one part of the story, today we are going to focus on the oscillator because it's often the main culprit in EMI emissions. So, why is EMI such a big deal in medical equipment? Well, take ECG, EEG, or pacemakers. They work with signals as small as microvolt or millivolt. Not extremely low. Any external noise, even tiny, can mess up the readings. And the thing about a modern hospital is packed with electronics in place like ICU. There are lots of life support systems running side by side. If one of them gets EMI interference, it could literally be life or death. That is why EMI has to be taken seriously. And since oscillators are often the primary source of EMI, that is the place to fix it. If we reduce EMI at oscillator level, we improve the entire system's reliability. Over the years, engineers have tried a few different ways to reduce EMI. First one, ferrite bits. That help a bit, and that is cheap and compact, but not great for the heavy EMI. The second, EMI filters. These works okay, but cost more and take up the more space. Third one, the metal shielding. Very effective, but expensive and buggy. Not ideal when space and cost matters. Now here's a good news. We offer something better. Mercury's low EMI spectrum oscillators. They are low cost, take up no extra space, and fully pin-to-pin compatible with your existing designs. Just drop them in, no redesign, no extra components, and they are okay to go. Let me explain how spectrum works using a 100 MHz oscillator as example. The red waveform is traditional standard oscillators. As shown, its energy is sharply concentrated at 100 MHz. This results in a high EMI at a single frequency. On the left, we have spectrum analyzer data. The x-axis is frequency and the y-axis is dB, showing how energy is distributed across the frequencies. This is frequency domain. On the right, we have oscilloscope data. The x-axis is time and the y-axis is frequency. This is time domain. Now we compare the red waveform with the Mercury slow EMI space-spectrum oscillators shown in blue. When we use plus minus 1% standard spread, the oscillator frequency modulates from 99 MHz up to 101 MHz and back, forming a triangular waveform cycle. It does this smoothly and continuously, from 99 MHz to 99.1, 99.2, 99.3, all the way up to 101 MHz. Then back from 100.9, 100.8, 100.7 to 99 MHz. And it repeats this cycle over and over. This process is called frequency modulation. The modulation rate is typically 20 to 50 kHz, meaning the frequency sweep happens 20,000 to 50,000 times per second. What's important is that the average frequency remains 100 MHz. So even though the oscillators is modulating, the timing accuracy is maintained, making it fully suitable and for timekeeping applications. Looking at the EMI performance, the traditional oscillators produce a peak at 11 dB. Mercury's space-spectrum oscillators reduce that to minus 5 dB. That is total EMI reduction of 16 dB, which is a significant decrease in noise energy. By spreading the energy over a wider band, we effectively lower the peak EMI without changing the functionality of the oscillator or the system it drives. You might ask what the 16 dB reduction actually means. Here is how math works. At 3 dB drops means 50% less EMI power. A 10 dB drop means 90% less power. And the 16 dB drop, that is a 97.5 reduction in EMI energy. That is huge. With this level of EMI reduction, most of the system can easily pass EMC test, even tough one like CISPR 11, Class A for medical equipment. And if you need more, Mercury offers other options too. We support plus minus 1.5% spread or even greater suppression. The best part, no need to change your PCB layout. Just swap in Mercury space-spectrum oscillators in place of your existing oscillators. Here is another way to visualize it. With a plus minus 1% standard spread, your clock frequency shifting from 99 to 101 MHz in triangular waveform. That spreads the energy evenly over the range. So instead of sharp spike at 100 MHz, the EMI now spread across 2 MHz of bandwidth. This greatly reduces the peak EMI, which is what matters for passing EMC test. It's like pressing a sharp needle with a soft brush stroke. Less chance of poking through EMC limits. Let us summarize the key points. Space-spectrum oscillators reduce EMI by spreading energy over a wider frequency range, lowering peak emissions by up to 16 to 18 dB, maintaining the same average frequency and the timing accuracy, requiring no extra components or ball change. It is a simple, low-cost way to solve the EMI issues in your system. Some systems cannot tolerate any frequency higher than nominal, like 100 MHz. If you are using a chip or radio that is sensitive to overclocking, center spread might not be safe. That is where downspreads come in. Instead of spraying plus minus 1% center spread, 99 to 101 MHz, we spread minus 2%, which means the frequency shift between 98 to 100 MHz, never above nominal. This gives you EMI reduction without risk of going over the spec. Downspread is ideal for MCU, SoC, FPGA, and communication IC that cannot tolerate frequencies exceeding the nominal frequency. Certain devices are very sensitive to over-frequency input. For example, the first one, microcontroller rely on crystal timing. The second one, communication IC that follow strict reference clock limits. FPGA that require precise edge timing. If the clock exceeds nominal, even briefly, it can cause errors, data correction, or failed startup. Using a downspread oscillators guarantee the frequency always stayed at or below nominal, while still reducing EMI. It's a safe choice for frequency-sensitive designs. Here is a typical application case. Let us say you are using a 50 MHz oscillator to fit an SoC that accepts the maximum input of 50 MHz plus minus 100 ppm with center spread. It might go up to 50.5 MHz. That is too high. But with minus 1% downspread, it varies from 49.5 to 50 MHz, safe and compliant. Same EMI fan-piece, no risk of overfrequencies. This gives engineers peace of mind, especially during certification. Let us look at the actual EMI test data. We compared two configurations of medical devices clock at the 100 MHz. With standard oscillators, EMI spikes exceed 43 dB microvolt at 100 MHz, and harmonics at 200, 300, and 600 are well above 47 dB microvoltage, failing CISPR 11 Class A. With Mercury spectrum oscillators plus minus 1% center spread, the EMI dropped below 27 dB microvolt across all measured bands, a clean pass. The improvement is consistent across all harmonics, not just fundamental frequency. This shows how effective spectrum oscillators is in real-world testing. Engineers know how costly and time-consuming EMC failure can be. Multiple test runs, shorting modifications, and layout change. It adds weeks or months to product schedules. Mercury spectrum oscillators gives you a simple test fix for EMI issues. A drop-in replacement, no redesign. Peace of mind during pre-compliance and formal EMC tests. And the best of all, it works across different industries, medical, industrial, security, and more. Mercury's low EMI spectrum oscillators product lines includes package size 7x5, 5x3.2, 3.2x2.5, and 2.5x2 millimeters. The output type is CMOS. The voltage we have 1.8 volt, 2.5, and 3.3 volt. For the spread types, we have center spreads plus minus 0.5%, plus minus 1%, plus minus 1.5%. For down spread, we have minus 1%, minus 2%, and minus 3%. The modulation rates from 20 to 50 kHz triangle wave. The typical current 10 to 50 milliampere, depending on frequency and voltage. These parts are loss compliance AEC-Q 200 ready, and designs for drop-in compatibility samples are available now, including custom frequencies. Spread spectrum oscillators can be used in a wide range of EMI critical applications. First one, medical, such as ECG, EEG, SpO2 monitors, surgical imaging, and ultrasound. Industrial, it can be automation, sensor, and data acquisition. For consumer, it can be high-resolution displays, USB hubs. For networking application, it can be Ethernet, PHY, Wi-Fi modules, routers. If it has a clock and needs to pass EMI, it can be benefit from spread spectrum oscillators. Here is a real-world success story. A customer was building a compact ECG modules for hospital monitoring. During the certification, the products failed EMI testing due to the oscillator emissions. Rather than redesign the entire PCB, they contact Mercury. We provide a 7x5 spread spectrum oscillators at the 27 MHz, down spread minus 0.5%. The result, the modules pass EMI certification on the first retest. No layout change, no filters, and no shielding. It saves them time, cost, and engineering resource. Here are a few more examples from actual Mercury's customers. Company B, oscillator of 32 MHz with center spread plus minus 1.5% in infusion controller used in ICU. Company L, oscillator of 8 MHz with standard spreads plus minus 0.5% in live support head and heart system. Company V, this company uses oscillator of 25 MHz with standard spread plus minus 1.5% in medical grade IP cameras. It is the same design as their consumer model, just 8 low EMI spectrum oscillators to pass tougher EMI specs. Company N, they use an oscillator of 66.6 MHz with down spread minus 3% for ATM controllables. ATM must meet banking-grade EMI security standards. These are just a few ways spectrum crystal oscillators help customers solve their EMI problems in their circuit. To recap the value of Mercury's low EMI spectrum oscillators, up to 18 dB EMI reduction, no need for filter, shielding, or therapies, center or downspread options, small size down to 2.5 by 2 mm, full pin-to-pin compatibility, ideal for EMI-sensitive designs, and all of these with competitive pricing and the fast sample turnaround. Why choose Mercury? Over 55 years of oscillator experience. First crystal manufacturer in Taiwan, trusted by top-tier medical, industrial, and telecom brands. Wide range of spectrum oscillators, fast delivery, full customizations, application support from design to certification. Mercury's help you conquer the EMI efficiently, reliably, and affordably. To learn more or request samples, contact Mercury today.